Greetings, fellow mathematicians. We need to get a little bit creative with this problem. Now, we're integrating here tangent of x, and there doesn't seem to be any obvious choice for a substitution. None of our basic tips seem to apply, but as you progress through your Calc 2 course and learn other integration methods, one of the most important is to take your function that you're integrating and rewrite it. So let's rewrite tangent from its basic identity as sine of x divided by cosine of x. And by doing that, now we can keep in mind one of our tips here, the third one. We want to choose u so that its derivative is a factor. Now if we think here, if we choose u as sine, the derivative of sine is cosine, but notice cosine of x is not a factor. Be careful, when we say cosine of x should be a factor, it has to be in the numerator. Cosine of x here is in the denominator. So u as sine of x won't work, but let's try u as cosine of x. The derivative of cosine is negative sine of x, and we certainly have a factor of sine of x there. So let's choose u as cosine of x. Calculate your derivative for the differential. The derivative of cosine is negative sine of x. And we already anticipate from previous problems, the fourth tip, you might have to manipulate your differentials. So in other words, just bring the negative over, multiply both sides by -1 to get negative du equals sine of x dx. And now we can convert. We have here sine of x dx converting to negative du. So we get a factor of -1. And the cosine of x in the denominator, that'll convert to 1 over u. So our integral here is really simple, the integral of -1 over u du. This one, we can't apply the power rule if we were to rewrite this 1 over u as u to the -1. When the power is -1, that's the only case where the power rule fails. Instead, the basic antiderivative here is natural log. So when we integrate this, our antiderivative, the negative stays, and we get as our antiderivative negative natural log of u, or natural log of absolute value of u plus c. And now we just back substitute our u that we chose, which was cosine of x. So we get as our antiderivative, our answer, negative natural log of cosine of x. And that is one version for the answer here. Now there's another version that might be stated, like for instance in the back of a textbook or in other sources. We have a factor, a -1, and our basic properties of logs allow us to take a factor up as a power inside the logarithm. So if I bring up the negative there, we would have cosine of x raised to the -1, and be careful with notation. This is not the same thing as inverse cosine. When we have a negative first power of a quantity, we can think of that as being 1 over the quantity, and 1 over cosine of x, we recognize that as being secant of x. So if you want to, but you definitely don't have to, you can rewrite this antiderivative. Again, the negative comes up, and we get natural log of secant of x. And both of these are acceptable as your answer for this problem in a standard Calculus 2 course. Hope you enjoyed the video. If you did, like and subscribe.